CS50 has tasked me to create a final project, so here it is. This video will walk you through how I built my full-stack web application, deployed on an Ubuntu server using PM2, built with Flask, a Python web framework, pure JavaScript, HTML, and CSS. On top of this, there's an admin dashboard with many customizable features. Let me show you what I've actually built first. Starting off by logging in. This gives us access to the admin dashboard. Here we can add some categories. CS50's Introduction to Computer Science, the Science of Well-Being, and Justice. Now we can add topic cards to put in these categories. We specified the slug, which is what shows up in the URL, a title, and choose which categories you'd like this card to be visible in. A description, logos and colors for both black and white themes, then whether you'd like it to be published or not, and repeat. Going into these topics, there's nothing interesting yet. Back we go. Sections. Add some sections. Still pretty boring. So how about we give the section an item? These items have a title, a bookmark color, you choose the size of your item, and markdown content. It's just a simple way for users to type normal text, but also include a few simple codes to make their text look cool. And repeat. Wrong way around. And so are these. Weird. I'm done now, so we can log out. Right, do your eyes hurt yet? No problem. But as a light theme supporter, bring that back. There's some extra information at the bottom in the footer, and for quick navigation, we can use the search feature. What's this? How it's built? Good question. Starting off with a proper tree structure saves time. I'm sure my structure isn't perfect, but it's good enough for a website like this. Let's go over the models first. My website needs a memory. It needs to remember all the categories, topic cards, sections, and so on. That's what a database is for. This is all stored in a site.db file. But Python can't understand what's in a .db file. They don't speak the same language. So the models folder is basically my team of unpaid overworking translators. First, you've got the architect, schema.py. He only has one job. When the app runs for the first time and it sees there's no database yet, it'll create the tables I've told it to create and set up the full database structure. Now, if I've written all this right, I should end up with a nicely structured database. But how do we view this? Well, I'm using SQLite for this website, since I won't be storing huge amounts of data. I've opened up the site.db file in SQLite's database browser. Here we can see what exactly the schema file is creating. Then you have the universal translator, database.py. Its whole purpose is to make sure Python and the database can understand each other. It has a special feature called a decorator, called a DB connection. So when I add this one line above any function, it automatically does the work and opens a connection, lets my code do its thing, then closes it. It just manages the database conversation, so nothing gets messed up. So how does this all come together? Take the topic model class in topic.py as an example. When I call topic model getAllPublished, here's what actually happens. The DB connection decorator kicks in and opens a connection to the database, and hands the function a tool called a cursor. A cursor is like a pointer that lets you go through the results of a query, one row at a time. The function uses this cursor to send an SQL command asking for all the published topics. The database processes this command and sends back the results through a cursor. This raw data isn't very useful to my website yet, so the model's final job is to take each row and convert it into a proper topic model object. So for example, instead of having to remember that the title is in column 2, I can just use my topic.title in my code. Once my function has finished building this list, the decorator steps in one last time to clean up, closing the connection to the database. Wowee, that was a lot. So we've seen how the models handle all the data, but before we look at how things get to our screen, let's quickly talk about the architecture we're following. The MVC, Model View Controller pattern. In this, models handle the data, views handle what the user sees, such as the templates and static files, and controllers are the route functions that connect the two. You got it? Great. Now, how does that data actually make it to our screens? Routes. In our app, these route functions are called the controllers, responsible for handling requests, getting data from models, and selecting a template to render. Let's follow what happens when you visit the home page. The home.py file contains a route for the main URL, often just a slash. When your browser requests that page, Flask triggers the corresponding function. This function's job is to coordinate everything. It doesn't know how to get the data itself, that's the model's job. Instead, it calls on topic model to do the work. Then the controller passes the retrieved data to a template to render. Once the controller has the data from the models, it passes everything to an HTML template. The template is like a blueprint for the web page. It has the structure and design, but with empty slots where the actual content should go. The controller fills in those empty slots with actual topic titles, descriptions, and logos. This creates the complete HTML page that gets sent to your browser. I've briefly just gone over the templates, but let's go over it in more detail. Remember when I said the route passes the data to the template? If we look at the home.html template, you can see those empty slots I mentioned. For example, right here. The topic.title in between two curly braces is a placeholder. When the route passes the actual topic data to this template, Flask automatically replaces this with the real title from the database. Same thing happens with the description. The template is the structure, but it's the controller's job to fill in the actual content. You can see this pattern everywhere in the templates, in the admin dashboard, and even in the login form. At the top of these pages, you'll notice that it always mentions extends layout.html. This is using Jinja, Flask's templating system, to create a base template that all other pages build upon. The layout.html file contains everything that stays the same across the entire website. The navigation bar, the footer, all of the CSS and JavaScript links, even the search modal. Then each specific page, like home.html, only needs to define its content inside the block content section. This is incredibly efficient, because if I need to update the navigation bar or add a new global feature, I only have to change one file, the layout file, and every page on the site automatically gets the update. Now, I think we've covered all the core parts of the application, but there's still a few more. I swear we're almost done here. The static folder contains all the front-end assets that make the website look good and feel interactive. The CSS is organized into files. Base.css, for example, defines the color variables for light and dark themes. Components.css styles all the buttons, forms, and cards, while layout.css handles the overall page structure. Now, I know, I could have used Bootstrap instead of all this code, but anyway. The JavaScript files in the statics.js folder, on the other hand, are what transform the website into a dynamic, interactive application. The app.js handles the main features like the search bar and theme switching, whilst the admin scripts, admin dashboard, and admin sections, for example, power all the drag and drop functionality, letting the admins rearrange topics and sections easily. Utilities. This folder is mainly for functions that don't really fit into the models or routes folders. Upload.py is a great example. It's a dedicated imaging processing tool that handles everything from validating file types to resizing logos and managing file storage. When you upload a topic logo, this utility makes sure it's properly formatted, creating optimized versions, and safely stores it in the right location. Finally, server.py, the file that starts everything. When running this file, it imports all the controllers, initializes the database making sure all the tables are ready, and then starts the Flask web server. Once it's running, the website is live and listening for visitors, connecting all the work done to an actual audience. That's if you've launched it on a server. Deployment. I'm running this on an Ubuntu Linux server using PM2 to start the application. This runs the site in production mode and keeps it alive 24/7. The server itself is configured with nginx as a reverse proxy, which listens on the default HTTP port 80, the standard port for incoming web requests, and it forwards those requests to the Flask application. This setup is what makes the site publicly accessible to anyone on the internet, turning this from a local project into a real functioning website that people can visit and use. We're done. Now, I would be lying if I told you I had written all this myself. A big part of coding nowadays is learning how to problem solve, to use the tools and libraries provided for you, searching up solutions when you're stuck, and building on top of code you or others have written before. Lastly, AI has become an incredible resource. It's like having a coding partner that's read nearly every piece of publicly available code. But the real skill is understanding how it works, why it works, and knowing how to adapt it to your project. That's what it's all about, I think. This was CS50.